All right, hello everybody. My name is Sophie, and I'll be talking to you guys about learning to play StarCraft 2. I worked on this project with my wonderful team members, Edith and William. Now, high-level overview, I'll be talking about the problem and some relevant literature. Edith will come in with our approach, and then finally, William will wrap it all up with some analysis and results. Now, without further ado, StarCraft 2 is a real-time strategy game with a truly unfathomable number of decisions and states. Players are going to play as one of 3 distinct races, building structures and commanding units to serve the end goal of destroying the opponent's base. Now, with that in mind, we wanted to train a bot using AI techniques to play StarCraft 2, namely against a single opponent and with the goal of finding an optimal macro management policy. Macro management just being the high-level strategies to guide the game, such as the build order of structures and units. Now, I'm going to go through some relevant literature, such as AlphaStar, which is an agent created by the research lab DeepMind, which uses a mix of neural networks, imitation learning, importantly, reinforcement learning, similar to the advantage actor-critic method, and some multi-agent training. And for the sake of time, I'm not going to get too far into it, but I do think it's important to note that by 2019, AlphaStar was rated at the Grandmaster level, which is honestly quite the achievement. But moving into SARSA and gameplay, because it's a little bit closer to what we did, a lot of these new methods are looking into combining SARSA with neural network-based deep learning to solve problems like imitating human gameplay. Because StarCraft 2 and a lot of these other video games have states that are very high-dimensional and progress non-linearly, neural networks are used to approximate the state action value function through a process kind of like this diagram below, and then SARSA is used to update these state action values. Now, while we don't use neural networks, we are using SARSA. And so with that, I'll hand it off to Edith.
Hi everyone, my name is Edith, and I will take you to a tour to our approach breakdown to the problem. To get started, we decided on using SARSA learning to tackle this problem as it is perfect to use to determine the optimal policy of our game due to the nature of our gameplay. The agent will take action at some state, it receives a reward, and the game moves on to the next state, and it repeats. The state actions and rewards are defined over here. If you are interested, you can pause the video and take a look at them. Here is our approach breakdown. Our approach is breakdown into 6 total parts. To set up, all our bots developed are based on the Sharpy Python framework, which is linked over here. We created a heuristic guided bot that takes random actions at every state. The game is set so that our bot plays against an in-game AI, and we collect the data logs from those games we simulated. In total, we simulated well over 300 games for our data collection, and here is an example of our raw data output. During data phrasing, we clean and format the raw logs into files of SAR and SPARM tuples and feed them into our training process. The training process is pretty straightforward. We loop over all the states in every data set using a epsilon greedy algorithm to update the Q values of each state. Since we have over 50 entries for each state, the state in our policy will be nested to reduce time in finding the states corresponding to those ones in-game. These are some code segments of our scripts, and the lower right corner is an example of our policy output. Finally, it's time for some gameplay with our policy-driven bot. To analyze the performance of our bot, we decided to collect the win-loss ratio as our metric and observing the before and after differences and optimizing the bot as necessary. From here, I will hand it over to our bot expert, William.
Hi, I'm William, and I'm here to talk about our analysis and results. For our exploration bot, which executed a heuristic-guided randomness strategy, we had a 53% win rate against the in-game card AI. After training, we managed to improve that to a 59% win rate. Let's talk about some of the underlying challenges to creating a StarCraft 2 bot. First of all, there are many states, so we have to be smart about which aspects of the state that we keep in the model and which aspects to disregard. There's imperfect information of the enemy state, since there's fog of war. We only have sparse actions, where we execute one action per many game ticks. So we have to figure out how to model this effectively in a reinforcement learning context. The way we did this was that instead of only recording the actions that got executed, we also included the actions that the bot desired but were not able to execute. There's uncertainty of whether the chosen action is successful, and there's high computational complexity to execute the policy. Some future improvements could be using online learning rather than batch offline learning. This way, we'd have continual improvement where we'd be able to gather state information across a more relevant state space rather than staying near a random policy. And we also want much more training data. Thank you so much for watching, and see you next time.